Hello all, I'm Dr. Christina Liaghati, and I lead a lot of MITRE's collaborations in AI security. And today we'll be talking about AI threats and vulnerabilities, as well as our growing MITREATLAS collaboration as we work together to improve the AI security of our community. I'll hand it over to Jonathan now to introduce himself and get us started.
Hi, so I work closely with Christina at MITRE in our AI and Autonomy Innovation Center, where I work as a machine learning and security researcher. We're excited to talk to all of you today about some of the work that we've done and also done in collaboration with a number of others on AI threats and vulnerabilities. But to really start, I think it would be helpful to kind of set like a baseline about what we're talking about. And I think particularly for AI and machine learning, it's helpful to take a step back. And really it goes all the way back to the 1950s, in particular 1956 with the Dartmouth Conference. I guess infamously, some of these famous academics said that they would have this AI problem solved in a summer if they had the right people together. And we're many summers later, and obviously that was not the case. And instead, really, what happened was this kind of sequence of booms and busts and these AI winters. Some of these AI technologies kind of overpromised and underdelivered, but really along that way, they were building kind of the core mathematical foundation of the kinds of techniques that would be used and that we use today. And building that along the way. And really in 2010, 2012 timeframe, there was this real inflection point with this math being brought together with, this now kind of cheap, accessible, highly parallelized compute, typified by an NVIDIA GPU. And with the rise of the internet and the interconnection of all these different systems and digitization of all this data, these massive data sets that we were then able to apply to these mathematical techniques on the right kind of compute, leading to this real Cambrian explosion of different kind of AI applications against real and meaningful problem, and the associated ecosystem that has grown out of this. Across not just the traditional tech giants, but even companies, organizations, entities that we wouldn't traditionally consider to be technology or AI companies, but are finding these techniques to be extremely valuable in driving revenue, safety, whatever their kind of core function is. And we see that across industries, and I think cyber in particular has benefited from this. I mean, you can't hardly find a product today if you go out and look for it that doesn't use some kind of AI and machine learning. But you have this massive amounts of data coming in, and really what you're trying to determine is what are the meaningful kind of data points I need to look at. What are the relationships? What kind of activity patterns indicate kind of these malicious threats? And that's something that these techniques and AI and machine learning writ large really excel at, of being able to learn straight from that data and draw insights. But unfortunately, with this broad adoption, we've also kind of brought on and need to recognize these kinds of unique and new kind of vulnerabilities and challenges. Now, the example here is obviously quite trivial, but it kind of exemplifies the novel and kind of new nature of some of these vulnerabilities. And you see here, an otherwise performant image classifier that has a high level of performance on, in this case, identifying a banana. But using these kinds of techniques, that patch, you put it right next to the banana and immediately thinks it's a toaster. And unfortunately, it's not all just kind of these trivial examples, but there's this broad range of kind of vulnerabilities that exist across really the machine learning and AI supply chain that are becoming more and more meaningful, particularly as these techniques are applied to problems of much greater significance than classifying a banana. So, for example, the ability to essentially bake in a backdoor by poisoning the training data, or if you have kind of live online learning, to be able to actively poison that kind of capability. You see some examples here, kind of growing examples, but they're just a few that are public and in the public domain. Model evasion, everything from causing a Tesla to swerve into another lane to just appending the right kind of sequence of strings to a malware executable to get it to be able to easily bypass an AI-based malware detector. So in the case of model inversion, you don't really need to be have any type of like network intrusion or violation of a kind of like a typical security control or principle, but using the API level access alone, be able to extract potentially very sensitive training data. And so, in the example on the slide, we did this with celebrity faces, but as this is applied to PII, medical information, other things that are much more sensitive, this becomes a very, very serious kind of problem. And then lastly, the ability to wholesale steal, a model that you may have spent millions of dollars working on, developing, kind of priceless intellectual capital that you've poured into this, for example, with Google Translate, only to have that, essentially stolen using really just the model outputs to be able to break down, understand the kind of mathematical makeup of that model and the associated weights so that you can replicate something much cheaper than it takes to be able to build that thing itself. And so really, this is to highlight kind of like looking at these different kind of vulnerabilities and classes of those vulnerabilities. I wanted to call out some of the key differences from what we would traditionally see in cyber. So, unlike, the identification or discovery of a 0-day in traditional software, where you go in, look for, the quintessential overflow condition that, allowed remote code execution, et cetera, et cetera. The probabilistic kind of nature of these algorithms mean that, discovery is through a similar kind of probabilistic method where you work through kind of developing, either through the scale of, extracting the sensitive training data or the development of, for example, that patch used an approximation of the original model. But we see that these really easily transfer across model types. And, that means that fundamentally they can't be fixed by, a traditional software patch. This isn't something where you identify it and then you just, you roll it out on update, Tuesday. But instead, there's an inherent trade-off between performance and how performant that model is and how robust it is to these adversarial examples. So there's a number of different techniques to try and, kind of guard against these things, but they often or usually require kind of a downgrade in the performance of that model. And that's obviously a very difficult trade-off is, if you're using this model for, important revenue generating functions, you want it as good as possible. And then, on this kind of line, the last thing, and this is still, an unanswered question, but I wanted to point to some of the researchers out of MIT who've done a very good job of looking at this and kind of identifying that the kinds of things that we're exploiting in the cases that we just showed you are really features of these kind of class of techniques, particularly deep neural networks, but these are also there's techniques against a broad range of kind of the traditional machine learning techniques that are really features of what we're doing here. And so, this leads to this new failure cases, right? And, having to look at a scenario where you could have, quote unquote, perfectly secured the deployment of some, AI enabled service via API, but an attacker using these kinds of probabilistic methods can still have the same effect as if they had infiltrated your network and stolen the source code to that model. And also, some of the challenges is, different OEMs use these techniques in very different ways, implement them very differently to do things like, biometric authentication to services and devices. And we're beginning to see a lot of these hybrid attacks that kind of, bring together these techniques with, traditional kind of cyber goals, privilege escalation, stuff like that. And then also, kind of why we've driven towards the development of, this framework in collaboration with a number of others is that they're not really covered by traditional risk assessment and control frameworks. And, it can be very difficult to differentiate, these, meaningful attacks that you need to guard against from, more toy examples, right? Every single day we're seeing on these different like archive, somebody for their PhD thesis has published, a new attack, but, being able to work through and say, okay, like which ones really matter to me? For example, some of these attacks that you'd see in literature, require access to model weights and things like that, which is completely unreasonable because if an attacker has, gotten that far into your network, the last thing you're really worried about is like a tiny perturbation to your model. But, as we've kind of found in our work with, a number of folks and different red teaming events and things like that, there are a large number of these, or there are certain ones that you do need to pay attention to. And, it leads to like, there's real world impact. Unfortunately, this is no longer just a research question. And we're beginning to see governments and corporations losing, millions of dollars as these things are used to attack, their, critical implementations of AI and machine learning. And very similar to, the cyber domain, you really see this kind of tiered, threat actor, right? From, APT level threats to, script kiddies where, for example, the guy wearing the wig trying to, attack the, ability to fraudulently file for different, government assistance. But, all the way, on the left, there's these really sophisticated attacks that let some, Chinese hackers essentially, send out fake tax invoices and collect almost $80 million fraudulently from various companies. These things are real and meaningful, and we're seeing, unfortunately, particularly as COVID has driven the rollout of a lot of different AI-enabled technologies, as companies and governments try to continue to provide critical services to their customers and citizens, that they've often leveraged an AI-enabled service to provide human-level services at scale. And now attackers seem to be really going after those, and we see that kind of increase, and I think we will continue to see that increase as AI and machine learning is applied to problems in areas of critical importance. And as is typical, the progress in the technology and the associated malicious actors have really outstripped, efforts, particularly by, to be able to govern, regulate, et cetera. But, I think, and that's what's really inspired us, at MITRE, and as part of this broader kind of community that's working on this to kind of understand these attacks and understand how we can mitigate, against the risks of deployment, so that society can benefit from a lot of these really powerful technologies. We started working on, Atlas is this kind of bottom-up approach. Had the good fortune to kind of be able to brief that to folks from the National Security Commission on Artificial Intelligence, and we're now seeing with NIST, they're rolling out their AI risk management framework, this kind of groundswell of an understanding that this is something that we need to deal with. And, I think really what we'd like to see is this kind of community come around it to be able to build something that's useful, at a technical and a conceptual level, and that innovates quickly enough that it keeps up with the adversaries as they, use different techniques and procedures. So with that, I'm going to hand it over to Dr. Christina Liaghati to talk to you more about what we're doing to be able to work with industry, with government, with the bring the public and private sector together around this problem set to start working towards ways that we can mitigate and start identifying and reducing the risks.
Awesome. Thanks, Jonathan. So now we'd like to kind of jump into where we're at with MITREATLAS. We'll give some background on where we've come from and the exciting updates that we have for the future. The Atlas collaboration is inspired by MITRE ATT&CK to enable researchers to navigate the landscape of threats to machine learning systems in a rather familiar way. We built it out as a part of a broad community collaboration as part of this shared vision of developing a knowledge base of tactics and techniques and case studies for machine learning systems. We see it as really important that we come together in this kind of collaborative format to make sure that it's most useful to the broader community. This broad collaboration is really critical if it's going to be useful to the broader community, as I said, and we've really enjoyed and loved incorporating a lot of the feedback that we've gotten from a number of our existing partners in all of this. The feedback and case studies and really participation from the community has shaped what Atlas is today. As Jonathan laid out in the timeline, we originally released a raw canvas of Atlas. It was the adversarial machine learning threat matrix out on GitHub as a collaborative project in the fall of 2020. And we've matured it since then into where Atlas is today. But the community originally really engaged with this raw canvas and provided feedback and really incorporated a lot of the case studies that they had in their own environments, and it has made it a significantly more impactful contribution to the broader community. Atlas today itself looks very familiar to the MITRE attack framework. So it's meant to be a familiar environment for different researchers and security analysts as they're working in the same kind of world as the cyber side of the house. And we'll go ahead and jump into now and demo of the full MITRE Atlas website, and then we'll come back and talk a little bit more about how we'd like to get you all engaged.
Hi, I'm Danny from the MITRE Atlas team, here to introduce you to the Atlas framework. Atlas is a knowledge base of adversary tactics, techniques, and case studies for machine learning systems based on real-world observations, demonstrations from ML red teams and security groups, and the state of the possible from academic research. We built Atlas with our colleagues at Microsoft and from the feedback and submissions from many other companies and academic institutions. Atlas enables security researchers to navigate the landscape of threats to machine learning systems. Our goal is to raise awareness about the risks of deploying machine learning models, create a common framework for documenting and organizing adversary behaviors, and build a community of machine learning and security experts. You're looking at the homepage of the Atlas website, which is live at atlas.mitre.org. Atlas is modeled after the MITRE attack framework, and its tactics and techniques are complementary to those in attack. If you know attack, the Atlas machine learning matrix you see here may look familiar. Machine learning models have a novel attack surface that pose a new challenge for security analysts, and thus we have new tactics and techniques particular to ML-based systems. The column headers are tactics which represent the adversary's goal or the why behind their actions at a particular point in an attack. For example, over the course of an operation, the adversary may perform reconnaissance to learn about the victim machine learning model, acquire some level of access to the model, and use this to have some impact on the system. For each tactic, there are several techniques that document how the adversary will achieve their tactical goal. For example, if an adversary wants to gain initial access to a network, they may accomplish this by compromising the ML supply chain. There are sub-techniques that enumerate the potentially vulnerable parts of the supply chain. The Atlas matrix only lists tactics and techniques relevant to machine learning. In practice, machine learning models don't live in isolation. They may be part of some larger enterprise network. Let's jump over to the navigator. We've imported Atlas as a platform in the Attack Navigator. Here you can see the Atlas techniques in green alongside Attack Enterprise techniques. When machine learning is used in the enterprise setting, adversaries may use a combination of traditional cyber techniques and Atlas techniques to achieve their goals. The Navigator is a powerful tool for browsing Atlas and Attack side by side, performing analysis, and building visualizations. For example, we can highlight techniques according to their frequency in case studies to better understand likely threats to our ML. Here, the darker red boxes indicate that the technique was used more frequently. Now back to the main website. The matrix view provides a good overview, but we might want more detailed information about a particular tactic or technique. We can click on any of these tactics or techniques to learn more. For example, if we want to learn more about one of the new tactics, ML Model Access, we can click and be presented with a description of the tactic. In ML Model Access, the adversary may attempt to gain some access to a machine learning model. This is a key tactical goal in many attacks. It can help the adversary gain information, develop attacks, and as a means to input data to the model. Each tactics page provides a description of the tactic, a listing of techniques an adversary may use for the tactic, and the case studies that the tactic is used in. We'll get more into case studies in a moment, but first, let's take a look at the main techniques page. Again, techniques are how the adversary achieves a goal or what they gain. On the techniques page, we have a searchable list of all techniques. We can browse them by expanding any of the tactics, or we could also use a keyword search. Let's look at the Evade ML model to learn more. Model evasion describes how adversaries can use adversarial examples to prevent detection by a machine learning model. This technique may be used in the defense evasion or the impact tactics, depending on the adversary's tactical goal. We can also see that the Evade ML model is used in many of the case studies that we've collected. Now, let's move on to the case studies page. Each case study documents an attack on a production system. We found it important to ground Atlas in techniques observed in the real world and shown to be effective in practice. We collected 13 case studies that show a broad range of adversary behaviors, varied use of techniques, and several different tactical goals. The case studies are really at the core of Atlas. They helped us design the matrix-based feasible attacks. We added tactics for the new tactical goals we observed and broke up techniques into behaviors aligned with those goals. Each case study walks us through the step-by-step procedure the attacker used to carry out an attack. Let's do a deeper dive into one of these. If we select the case study bypassing Cylance's AI malware detection, we can see a summary, some additional information, and the procedure that the red team in this case used to carry out the attack. In this case study, researchers at Skylight were able to create a universal bypass string that, when appended to a malicious file, evades detection by Cylance's AI malware detector. The procedure is a step-by-step walkthrough of the attack. In this case, the red team used reconnaissance to learn more about the victim model. They gained access to the AI-enabled software. They developed their capabilities by probing this software. They created adversarial examples manually, and ultimately used them to evade detection by the malware detector. This is a great example of how using ML in security software increases the attack surface and opens up the system to new ML-based techniques. Finally, I want to share how you too can contribute to Atlas. Atlas is a community effort. Please send us any feedback or suggestions to atlas@mitre.org. Also, consider submitting a case study for inclusion on the website. Case studies can come from your internal red teaming efforts or observations of adversary behavior you've observed on your network. Thank you to everyone who has already made major contributions to Atlas. We hope that you will find Atlas to be a useful tool to learn about ML techniques and adversary behaviors, build threat intelligence reports, share case studies from your own red teaming exercises, or assess the defense posture of your deployed machine learning, among other things. Thanks for listening.
As Christina said, this is something that we really, from the ground up wanted to make sure was based off of, kind of real world validated examples of this, and that it would be useful to the security community. We understand that not, every organization that's using or even developing, AI and machine learning tools is going to have the luxury of, like we do, of having our own AI red team or, working with Microsoft or Google's AI red team. And so, a core piece of what we're doing is we want to, similar to Attack, be able to link these kind of higher level conceptual frameworks with like real tools that security researchers and security practitioners are, used to and familiar with. And so, that they can understand the threats at a technical level and understand the effectiveness of their various mitigations against those. And so on the upper left-hand corner, you can see, Microsoft Counterfeit. It's been published by the team that we're working very closely with and to develop the Atlas framework, as well as, we're working actively internal to MITRE to develop various plugins to Caldera so you can run kind of automated adversary emulation, including some of these AI and machine learning attacks. And then on the right-hand side, you can see how, just organically, naturally, Atlas integrates with, the various attack, frameworks, whether you're looking at the cloud or containers, et cetera, whatever is meaningful to your organization. You can load that all in together on the Attack Navigator, understand the kind of risks and vulnerabilities, test those with real concrete tools, and begin to mitigate any of those risks, right, that we've identified with various case studies, et cetera. And we see this as continuously growing. This is not something that's static, and obviously we're super excited about the community engagement that we've gotten and the advancement. You can see how much it advanced in just 2 versions.
Awesome. Thanks, Jonathan. We're excited to continue moving this forward, and we'd like to invite you all to participate in where it's going in the future. From our perspective, MITRE has continually benefited from the contributions and participation from the different organizations involved in all of this, and we think the broader community is benefiting from it as well. So we hope that you'll actively engage with us and the broader community, and we've got some links on the next slide to give you different opportunities to engage with us on Slack channels, and through our different email and online formats. We've got a lot of different lessons learned and AI security conversations happening in those kind of formats The broader community contributions to Atlas have really given us insights into what the community is seeing outside of our focus areas, and it's helping us focus some of our machine learning research and development work as we're diving in on how to protect critical data sets and developing new machine learning security techniques. As we continue to build relationships and work with all of you, we realize how important it is to have the right mechanisms in place to collaborate. So we're excited to continue growing out our collaboration mechanisms for future AI research and development with all of you as well. All right, thank you all very much for listening to our full talk on AI threats and vulnerabilities. As I said, please email us at atlas@mitre.org and join our Slack channel to participate in a lot of the broader community conversations in this space. We hope to hear from you soon.